and growth in satellite sensing, communications, and dual-use technology that affects Earth systems. But hype still exists, especially when space is framed as an escape hatch from Earth problems. The reality is physics and economics don't care about the story. Most progress is incremental and built on reliability. Different bottlenecks, but same story. The bottlenecks here are often unglamorous: manufacturing scale and quality control, supply chain fragility, workforce specialization, test infrastructure, and regulation and safety culture. And for long-duration environments, human-centered design is still maturing. Psychology, social dynamics, habitability, maintenance over time, for example. That's a major area where architecture and human factors become essential.
So now that we're in 2026, it seems like the space industry has even higher goalposts this year. Do you feel like it is doing exponentially better than the architecture industry, or are they about the same?
Architecture is still a massive real economy industry. Tens of billions in the US, hundreds of billions globally, but it's growing more steadily than space, which is being pulled forward by services and constellations. When people ask me how real these industries are in economic terms, the numbers help ground it. On the architecture side, in the US, the architecture industry is estimated around $65.7 billion in revenue in 2025. Big, mature, and growing, but generally steady. On the space side, the Space Foundation reported the global space economy hit $613 billion in 2024, and about 78% is commercial. So space is no longer a government-only story. In the US specifically, you can see that shift in company scale numbers. Reuters reported Elon Musk projecting SpaceX revenues around $15.5 billion in 2025, driven heavily by the commercial services like Starlink plus launch. Where people start using the word exponential is launch capability. Starship's stated goal is up to 150 metric tons to LEO fully reusable. That's a capacity discontinuity. And in 2025, you can feel the US cadence building. SpaceX flew an 11th Starship test in October, moving toward an upgraded variant aimed at the Moon/Mars architecture. Blue Origin also hit a major milestone with New Glenn, deploying NASA's Escapade spacecraft and successfully landing its booster in November. My honest take is cost and cadence can improve fast and look exponential early, but it'll likely be an S-curve as the bottlenecks move from launch to everything else: payload production, regulation, orbital sustainability, and the real-world demand for all that capacity.
Do you believe life exists beyond Earth? And what's your probability estimate?
Yes, I absolutely do. I try to hold that opinion with humility, of course, because we don't have direct evidence yet. But if you force me to put a number on it, I'd say the probability that some form of life exists or has existed somewhere else is quite high, maybe even 99.9%. I think it would be rather egotistical or narrow-minded of us to believe that we are the only intelligent life in the universe. I mean, when you look at the scale of the universe and the number of planets, it becomes hard to believe Earth is the only place where chemistry crossed into the line of biology. And we already know that the building blocks, water, organic molecules, aren't rare. They're found everywhere in the known universe. I wouldn't be surprised at all if we at least discover concrete evidence of microbial life on other planets in our lifetime. But the reason this matters to me isn't just curiosity, it's perspective. If life is common, it puts a kind of ethical responsibility on us to treat life as precious and to build systems that protect it on Earth first and eventually beyond. And even if we never find life elsewhere, the act of searching forces us to understand our own planet better, how environments sustain life, what resilience actually means, and how fragile complex systems can be.
If we discovered microbial life tomorrow, how would that change your view of humanity's future?
Oof, a bit of gravitas with this one. But I believe it would be one of the most profound shifts in human perspective in history, because it would mean life isn't a one-off accident. It's something the universe can do, and systematically so. And that would make the question no longer, are we alone? But how do we behave now that we know life can exist in multiple places? What is our responsibility then? Big old questions there. For me, it would increase the urgency around two things: stewardship and expansion. Stewardship, because Earth becomes even more clearly a life support system that we can't take for granted. Expansion, because if life can persist elsewhere, it strengthens the case that spreading out isn't science fiction, it's part of life's long-term strategy. It would also reshape ethics. We'd have to decide how to explore responsibly, how to avoid contamination, and how to respect environments that might host life. I think currently this is more of an idea than a reality, but it will become more detrimental in practice. And oddly, it would make architecture feel even more relevant. Designing environments that sustain life, air, water, comfort, psychological well-being, becomes a universal problem, not just a terrestrial one.
So as we know, you worked at SpaceX. What's one myth people have? And one surprising truth?
A myth is that it's all glamour, rockets, big launches, dramatic moments. I mean, it is all that too, of course. But the truth is, it's a lot of detail work and an abundance of iteration. A huge amount of progress comes from small improvements compounded over time. Process, testing, manufacturing, learning from failure in a structured way. Even mistakes or failures are data. I met some of the most hardworking and kindest folks there and felt lucky to be part of the journey. A surprising truth is how mission-driven the environment feels. People are there because they believe the goal matters. We all came there with a mission in mind, sometimes fanatically so. That doesn't mean it's easy. It's demanding. But there's a clarity that comes with working towards something that concrete. I'm no longer there, of course, but I still very much believe in the mission. I'm still cheering on my team and absolutely blown away by everything they're accomplishing. I love being a small part of something so incredible. Watching it grow in the past few years and build momentum has been so exciting. And from a design mindset perspective, what I took with me is the discipline of constraints. In aerospace, constraints are real and unforgiving, and that creates a culture where you learn quickly, verify assumptions, and build for reliability. And I think architecture is moving into a world where constraints, climate, energy, cost, resilience, are becoming just as real. So that cultural lesson from that environment are relevant beyond rockets.
Elon often talks about the mission being to make life multiplanetary and the importance to colonize other planets. Explain what make life multiplanetary means to a super skeptical person in 30 seconds. What's your pitch?
30 seconds, huh? I'd say making life multiplanetary is basically risk management for civilization. Earth is our home, and we should protect it. No debate. But if you put all of humanity and all of our knowledge on one planet, you're betting everything on a single point of failure. That's dumb. A second self-sustaining foothold doesn't replace Earth. It complements Earth. It's like having backups for life's most important data. I mean, we have backups for our family photo albums, so I think we can agree that we should have backups for humanity's blueprint too, right? And not just humanity, but wider scope, all life on Earth as we know it. And the side benefit is huge. The technologies and design thinking required, closed-loop systems, efficient energy, resilience, compact livable environments, feed back into better solutions for Earth. So it's not a lofty form of escapism. It's a long-term survival strategy that also makes us better stewards here in the process.
Explain sustainability to us. What are some of the highest leverage moves?
Put simply, sustainability is the discipline of not borrowing from the future in carbon, energy, water, or human health. The highest leverage moves are reduce demand, electrify, decarbonize materials, and design for adaptability. Reducing demand is underrated. Envelope performance, shading, orientation, airtightness, appropriately sized systems, design that works with climate rather than fighting against it. Electrification matters because it aligns buildings with a cleaner grid over time. Embodied carbon matters because materials are upfront emissions. Choices in concrete, steel, and insulation can swing impact dramatically. The boring but massive leverage would be retrofits. Most of the 2050 building stock already exists. Envelope upgrades, system replacements, and controls can cut emissions at scale. Another underrated leverage is durability and maintainability. A building that lasts longer and can change use without demolition is inherently lower carbon. Design for disassembly, modularity, and serviceability matter.
Moon base, Mars base, or orbital habitat, and why?
If I have to choose one as the most meaningful near-term step, I'd say the moon, but as a proving ground. It's close enough to iterate. Shorter travel time, easier resupply, faster learning cycles. You can test habitats, construction methods, and life support strategies with a more forgiving timeline than Mars. Mars is the big vision, of course, because it forces true self-sufficiency. Mars pushes you toward closed-loop living, local resources, and long-duration habitability. That's the real second home challenge. And orbital habitats are fascinating because they could scale and support industry, research, and manufacturing in microgravity, potentially becoming a different kind of infrastructure layer for humanity. It's not just space tourism anymore. But I do think there is value in overcoming some of the challenges on the moon and Mars first, as that data will greatly aid performance metrics for space habitats in the future. So moon for iteration, Mars for civilization level resilience, orbit for scalable infrastructure.
What are your thoughts on artificial intelligence? Useful versus dangerous? Where do you draw the line?
To me, AI is useful as a force multiplier for exploration and reducing friction. It can accelerate precedent research, organize information, draft communications, and generate early options, and supporting documentation workflows when supervised. But as far as creative sandbox goes, AI can greatly help us to prototype new strategies, investigate design options, and think outside the box. Trial and error can be much less expensive. These are great for time management and in early conceptual phases for design. Where it becomes dangerous, though, is when it creates the illusion of certainty. The risk isn't that AI makes mistakes, it's that humans stop verifying because the output sounds confident. So my thought process is AI can help you generate and organize, but it cannot be the final authority for decisions tied to safety, compliance, and accountability. Anything that affects life safety, building physics, structural reasoning, or mission-critical systems must remain under expert judgment and verification, which is why I don't anticipate it completely replacing architects in the industry as some fear. We also need norms around authorship and responsibility, disclose usage, validate claims, and document assumptions. Keep humans in the loop. And don't get me started on the climate energy issues. Used well, though, AI frees designers to focus on systems thinking, ethics, taste, empathy, and leadership. Used lazily, it produced generic, uninspired, lazy work and brittle decisions. When I started the architecture program at UT in 2010, one of my professors introduced the program with a line I will never forget. The number one rule of architecture: don't kill people. And I believe we have an ethical responsibility to be of service in this industry and always keep that in mind whether we're using AI or not. Brittle decisions can create extremely unfortunate outcomes, so we should not be overly reliant on AI and seek balance instead of dependence.
What will buildings need to do in 10 to 20 years? And how is ASTRAEUS a prototype?
In 10 to 20 years, I think buildings will be expected to do 3 things more than they do today: adapt quickly, perform verifiably, and support human resilience. I'm going to break that down a bit, though. Adapting quickly means spaces and systems that can change program and technology integration without demolition. Static buildings become liabilities when the world keeps shifting. Perform verifiably means moving from vague promises to measurable outcomes. Energy, carbon, water, indoor air quality, thermal safety during outages, life cycle maintainability. The expectation of evidence will become more normal. And when I say support human resilience, it means buildings that help people stay well under stress: heat, smoke, isolation, social fragmentation. Through community space, access to nature, good acoustics and light, and layouts that support both connection and privacy. ASTRAEUS is a prototype because it's designed as a platform for that future. Modular and phased so it can evolve. A studio connected to labs and fabrication so ideas get tested. Interdisciplinary teams so solutions are systems level. And sustainability treated as performance, not branding. If it succeeds, the ripple effect is a new normal. Built environments that behave more like living systems, iterative, measurable, and human-centered, as well as organic, so we can keep up with the pace of change without losing what makes places meaningful.
You've referenced sci-fi like Dune, Foundation, and Interstellar in the past. What do those stories get right about the real future challenges of spaceflight? And what do they reveal about issues we're already facing on Earth?
I love this question, because those stories aren't really about rockets at all, but so highly relevant in today's culture and trajectory. They're in essence about the human systems that form around scarcity, power, and long timelines. Dune is basically a masterclass in ecology and resources politics. It's saying when one resource becomes the bottleneck, power consolidates around whoever controls it, and the environment is shaped by that destiny. In real space settlements, the spice won't be mystical. It'll be water, oxygen, energy, food production, and reliable maintenance. And that means habitat design is inseparable from governance. Who has access, how it's rationed, who owns the infrastructure, and how you prevent a kind of life support feudalism. Foundation zooms out to institutional resilience. You can have incredible technology, but if you don't have stable systems for education, legitimacy, and coordination, societies fragment and dissolve, especially when distance and communication delays create pressure for autonomy. You see the fall of civilizations in real time. All the old gods and old ways of living are dead or dying, and everyone is just trying to figure out what's next and what is survivable, and that can make people revert to more primitive means of coping strategies and existing. So a multiplanetary future isn't just can we build the first habitat, it's can we build continuity across decades, repair culture, knowledge transfer, adaptable infrastructure, and community health. So the settlement survives leadership changes, economic cycles, and inevitable failures. And better yet, survives time. Interstellar is the emotional reality check. It links spaceflight to planetary instability, but it's honest about the cost, sacrifice, uncertainty, and the fact that physics doesn't care what we want. It also warns that under climate stress,